Welcome to the Cables to Clouds podcast. Cloud adoption is on the rise, and many network infrastructure professionals are being asked to adopt a hybrid approach. As individuals who have already started this journey, we would like to empower those professionals with the tools and the knowledge to bridge the gap. Hello and welcome back to the Cables to Clouds podcast. You know the deal. We are back again with another great episode for you guys today. Today we're talking about VPC Lattice. So we've got some individuals on from AWS to talk about this relatively new service. I will say we had a great conversation. Prior to that, let's get into the bi-weekly cloud news of the week. Alex, you want to start us off with some news about AI? It's going to keep probably popping up every single time we release this now, but let's hear it.
Yep, it's going to be the thing every time, it seems like. So this is from the Google Cloud blog. It's about Falcon, which is a new, they call it a reliable, low latency hardware transport. What I thought was really interesting about this article is that they talked about how in the past they've released things through the IETF and ACM. And this time they decided to skip that and just release it with Open Compute Project. So it's just, interesting. I don't know if this is like a sign of changing times where people are going to start trying to get things through quicker. But it's got a bunch of backing, especially we talked with Peter Jones from the Ultimate Ethernet Alliance. It's got a bunch of backings from them. Like there's all kinds of quotes about all the different companies backing this. So I just think it's cool to see industry giants, if you will, coming out with these new standards. And then, next we got NVIDIA and OCI. Chris, if you want to talk about that one real quick.
Yeah, so we have an article. This not surprising here. Two tech giants starting an AI services offering, but so we have an article from SDX Central that NVIDIA is now launching an AI service offering on OCI. So probably very good for OCI to make this make this agreement, get their name in the game a little bit. I don't know if this is going to be exclusive to OCI from NVIDIA's perspective. I feel like they might be locking themselves in if that's the case, but I don't know. It's nothing surprising here. Just wanted to call that out. Yeah, next up we have some interesting news from well, we have CSP news next, but this last 2 weeks has pretty much been all AWS. So let's hear about it, Tim.
Yeah, no, big announcements actually on the cloud networking front from AWS, huge ones. The first one is that now AWS Cloud WAN supports tunnelless connect, which is to say, before Cloud WAN being kind of the managed WAN service, we had an episode where we talked to Ruskin Dantra about it, and we have a demo of Cloud WAN on our YouTube channel, so make sure to check that out. But they've just introduced a new way to connect to Cloud WAN without using any kind of tunneling or GRE, which is going to boost throughput, and it's going to make networking a lot simpler. So I've been actually playing with it. At work, just trying to lab it up, and it's really interesting. I think it could change the Cloud WAN game and get a lot more adoption. Unsurprisingly, a lot of NVA vendors, pretty much anybody with a NIC, has announced that they now support tunnelless connection with Cloud WAN. So yeah, it's pretty much everybody on the list. You can check out the news in the show. We link you to the biweekly news in the show notes. It looks pretty good, is all I can say. So there's another big one, and I think, was it Chris? You were going to cover this one?
Sure. So I think this is potentially a game changer for players in the especially in the networking market for AWS, but kind of just a big one for cloud networking in general. AWS has also made an announcement that they now support multi-VPC E&I attachments. So just to kind of break that down, typically whenever you deploy anything in AWS that belongs to a VPC, all the network interfaces that belong to that particular instance have to be maintained in that single VPC where it's deployed, right? But now they've announced that you now have the option to attach secondary network interfaces that can belong to a different VPC. So that's like, it sounds very simple, but that's huge and can kind of completely change how you build out networking, especially across VPCs, right? Because you could just have an NVA or just an instance of your choice sitting between two VPCs. They mention in the article that you can overcome CIDR overlap limitations, things like that. Really funny that they just kind of squeezed this one out, and it was kind of like not a big deal because that's pretty huge. And I don't know. I'm wondering if they've put this out. The timing is weird, right? We're at the end of October, and I'm wondering if they're putting this out just so it can coincide with something else that comes out at reInvent. I could be wrong, but I'm hopeful anyway. I hope it leads to something cool.
It's so weird because even this link is so short, and it's like it seems like it should be such a bigger deal, but
right?
this is like the first thing you learn. Like if you've ever taken any kind of training course or even Amazon's materials or AWS's materials, right? It's like, this is one of the first things is that the NIC is in a specific VPC and you can't like have them split. So this is, I don't know. There's so many weird things to think through with this, that new architecture changes. And it's almost like, I don't know if this is just to open up like possibilities for more people to use the cloud. Because one thing they mentioned is like a cheaper makeshift HA deployment. I don't know. It's weird. It's like it takes away from use of some of the other products that have come out. But at the same time, like it kind of opens up the door for new things. I don't know, Tim, you got any more thoughts?
Yeah, no, I mean, it's big. And what I find interesting is how low key the announcement was and how low key the actual, when I say the announcement, I mean, not only the announcement itself, but like the and I hesitate to even say article, right, about that this is now a thing that we're supporting. I don't know. Maybe you're right. Maybe it's just bearing the lead on something that's going to be announced at reInvent. But this is a huge deal that changes fundamentally the architecture of networking in AWS, or at least gives you the ability to change fundamentally that architecture. We can get NVAs in the data path now without having to do like kind of weird service insertion routing, and there's just so many. Like my brain was blown up since I saw this, and I'm already excited about all the options. What do you think, Chris?
Absolutely, yeah. It's like I said before. I'm hoping this leads to something bigger, but even on the surface, if this is it, this is still huge. This will definitely change the game for sure. All right, and then to wrap out the news, we got some growth and earnings reports from each of the top three. We got AWS, Microsoft, and GCP. So let's get into it. How did they fare this go around?
So Alphabet, which is the parent company of Google, pretty much went a little less than flat. Like they missed the expectations. All the expectations were missed, although not by a huge amount. That was the first one I managed to see. Of course, Amazon or AWS announced theirs just yesterday, so we had to kind of wait for all three to really draw any conclusions. Surprisingly, maybe not surprisingly, actually, Azure completely crushed their number, like absolutely blew it away. The expectation was like 23.6 billion, and they came in over the top. Or 23.6 billion, sorry. They came over the top with 24.3 billion. So like a full 700K over revenue expectations. But then their growth is absolutely nuts. They expected 27%, got 29%. And all I can think of is, in this economy?
Just a slight correction, not 700K over, 700 mil over.
Oh, sorry, I said some. Yeah. Good call.
Yeah.
I said K. Yeah, sorry. I should learn how to.
Yeah, we're talking big boy numbers here, Tim.
These are CSP numbers, not enterprise numbers, right?
Exactly.
Okay, and then AWS. So here's the thing: AWS is like the 800-pound gorilla of CSPs, right? So when you get to that size, any growth is hard won, and here. They grew their revenue percentage by about 12%, but the actual revenue number stayed almost exactly flat with what it was. The growth number is the same as it was in Q2. So we're just seeing basically just kind of treading water, keeping going from AWS rather. What do you guys think about that, Alex?
Yeah, I mean, obviously the Microsoft one to me is just crazy. I mean, is this, I guess I haven't been paying attention like historically, but more revenue than AWS, right? Like, is this like a new leader? Like, this is a weird moment, it seems like. And 12% growth for AWS compared to 29% growth for Azure. those are insane numbers. Wall Street is like, if AWS we'll take GCP, right? Their stock fell after they missed by 200 million.
Yeah.
Like Azure beat by 700 million. Like that's just the numbers are just insane. So it's crazy. Chris, you got any more to add?
Yeah, I think it's very interesting, especially because I don't even think, I'm by no means a financial guru or anything, but I don't even think we really have time, or we've had time for these generative AI services to even have an impact on the bottom line in these earnings reports yet, right? So it's like,
oh yeah, we haven't seen
this is drastically probably going to change. It's in the near future. But I mean, with the Google thing, I feel like, we talked about this earlier, I think on our episode with Peter Jones, is like that generative AI market is definitely eating into Google's ability to deliver on all fronts, right? They've got bigger fish to fry. The cloud market is kind of like not an afterthought, but it's obviously their I would say their side project. The advertising and everything is their main market, right? And they're and now they're dealing with the anti-compete restrictions and things like that. But Tim, you said people are acting like this is the end of the world for Google, like on social media, like everyone was blowing up. But it doesn't seem that.
I was surprised.
Huge.
Well, maybe the expectation was higher. I'm not sure, right? Like I don't watch Wall Street, so I'm just like you, right? I got real work to do, But no, I mean, it's true. Like everybody was kind of like, oh my God, this is it. Like, has Google peaked?
Here comes Google.
Everything.
Yep. They're going to cut the service. If you're on GCP, watch out. It's going to get killed.
That's the problem, is that Google's kind of like, made their own bed, with their willingness to just kill stuff.
Okay, so let's get into today's episode. So as I mentioned at the top of the episode, we have a very detailed discussion with Justin Davies and Alexandra Huides from AWS. I will say, if you're plugged into the cloud networking world on LinkedIn at all, you've definitely see Alexandra's name come up. She's always posting about new and exciting stuff.
Always.
She's always on their Twitch stream talking about networking. She's a great advocate for it. So it was really exciting to be able to have them on the show today. And talk about VPC Lattice, which is, a game changer for not just cloud networking, but specifically application networking. And, there's kind of been this unsureness amongst networking people about, does this take away, some of the capabilities and things for network engineers? And we definitely cover that in the episode. And I think they were very transparent and it turned into something really good. So hope you guys enjoy it. Coupled with this episode, we also do have a video demo that is part of the Cloud DeMISTified series for VPC Lattice. So really cool stuff. AWS actually provided us with some exclusive content. Two of their cloud networking solutions architects provide a demo of deploying multi-stack applications, multi-IP stack, I should say, applications on VPC Lattice. So check the show notes if you after the episode, if you want to get a little bit more meat off the bone, so to say, for VPC Lattice and see some actual implementation. And it's really cool. So hope you enjoy it.
Hello, and welcome back to the Cables to Clouds podcast. My name is Alex Perkins at Bumps in the Wire on Twitter, and I will be your host for today's episode. Joining me are my two co-hosts, Tim McConaughey at Juan Golbez and Chris Miles at BGP Maine. How you guys doing today? Chris, what have you been up to lately?
Not much, man. It's a very early day for me today. So luckily we were talking about this earlier, but I'm up before the birds. So hopefully we don't get too much chatter from them. But we have some lorikeets that love to come and eat sunflower seeds and grapes and stuff like that off of our windowsill. So hopefully they don't show up right in the middle of this, but otherwise I'm doing good.
Awesome. All right. Tim, how about you? What have you been up to?
Well, not much. We had Father's Day yesterday. I went to the Ashboro Zoo with the family. We did the whole Zoofari thing where you ride around in one of those zoo buses, like inside the enclosure, and get side-eyed by rhinos and stuff like that. It was all right. It wasn't too hot, and we had to head home early because had to let the dog out and everything, but it was good.
Nice. I have yet to go, but my wife's like entire family that lives out here goes all the time. So I'm sure I'll be going sometime this summer real soon.
It's a good zoo, man. You should go.
Yeah. I know our last recording, I was just talking about how the weather was so beautiful out here. It is supposed to rain. Today's Monday. It's supposed to rain until Sunday. So
Nice.
there goes that weather. That was so great. All right. Well, today we have two very special guests, Alexandra Huides and Justin Davies from AWS. Why don't you guys go ahead and introduce yourselves, and then we will jump into today's topic. So, Alexandra, why don't you go first?
Awesome, thank you. So, happy to join you folks today on the podcast. My name is Alex Huides. I'm the second Alex here on the podcast, so we should make sure we don't confuse each other. I'm a networking specialist solutions architect with AWS and strategic accounts. And one of my areas of focus and interest is how to help AWS customers simplify their network architectures. And we are here today to talk about one of my favorite services. So yeah, I'll keep the suspense a bit, not share the name.
Hey everybody, I'm Justin Davies. I'm a product manager in the EC2 networking organization in AWS, and I focus on kind of the higher level stack of networking. So we call it application networking. VPC Lattice is one of those, and I've been at Amazon for about 7 years now. But I think traditionally I'm more of a regular networking person. Cisco, Juniper, all those kind of things are my background. But Amazon obviously turned that upside down, and I had to learn a whole different kind of fake networking. So that's the stuff I work on now.
Awesome. Well, yeah, good that you guys both come from more traditional networking backgrounds, right? Because that's really the point of our podcast, is bridging that gap. And yes, as Justin called out, so today's topic, so really it's another installment of our Cloud DeMISTified series, as we're calling it. And the topic this time is another AWS product called VPC Lattice. And it's pretty new. Was it just announced last reInvent?
Yeah, we announced it as a preview in November at reInvent, and then we took it GA end of March, one day prior to the end of the month.
And this product, I guess, really has taken a lot of ideas and kind of meshed them all together into one. And I think it's changing a lot of the ways that people are looking at networking. I know the three of us talk about it all the time, about all the cool possibilities and ideas and designs you can come up with. So the goal today isn't really necessarily to do a deep dive as much as we'd love to, right? It's going to be kind of hard to do in an audio format. But it's really more just to get a handle on kind of how it was made and what it's designed for and the things it can do and the architectures you're seeing come out, stuff like that. So I guess why don't we get started with a brief history of VPC Lattice?
I think Justin here is the person who can share that from the beginnings.
Yeah, so I mean, I mentioned it earlier before. Been at Amazon for about 7 years now, and when I originally came on, I was a solutions architect, like what Alex is working on, and a lot of the time, it was really deep networking stuff. It was like, how do I connect my big data center with your big data center? And how do we do all these kind of complicated things for really advanced customers? And that was kind of like a fun little journey up front, because everybody was kind of just figuring out, like, can I trust the cloud? Can I move to the cloud? Can I do this kind of thing? That kind of transitioned. Like, there's not many customers that are like scared of the cloud anymore. I mean, sure, there's some, but most customers are like, okay, cool, I can kind of trust Amazon, right? Like, this is okay. And so when you do that transition, a lot of the time people went with that whole, what we call lift and shift model. They just take whatever they know, they move it to the cloud, which is great. It allows you to move really fast, gives you an API for a lot of the things that you're used to. But when you get there, then you got to try to figure out, okay, is this optimized? Chances are it's not, right? Like, doing the same thing you did back in the day in a traditional network, if you did it the same way in the cloud, it probably would be more expensive. Probably would be even, all the things that are just not good. And so usually they use that as a migration pattern, and then they try to figure out, how can I optimize this over time? Now, so this is the one step, right? It's just like, okay, moving to the cloud, getting there, getting used to things. And we built a lot of the primitives to help customers get there, right? VPCs, it's kind of like a virtual data center with an API. It's got route tables, it's got subnets, it's got network ACLs and security groups, which are like little firewalls that you can put on instances. And then customers didn't just build one virtual data center, aka VPC. They built a ton, right? They built hundreds of thousands. And so they needed to connect these kind of things. And dealing with them onesie twosie with VPC peering was kind of crazy. And so then we built virtual routers, right? Things like the transit gateway, and allowed customers to do all this kind of stuff. And that was kind of solving these like network level tasks, right? So now there's that part. But when you look at what these people are bringing to the cloud, the applications that they're bringing to the cloud, it isn't just routers and switches, right? Like there's an application on the ends of these things, right? The internet with a bunch of routers and switches with no application on either end would be super boring, right? So you need something on the other side. And this is where you need some higher level stuff. Service discovery could just be DNS, things to actually figure out where I'm going. So they can have a DNS URL. Application load balancers, how do I actually load balance and scale up, scale down, all that kind of stuff. If you're more advanced and you're more security conscious, things like authentication, authorization, all those kind of things. This is all kind of what helps build application networking, right? You got that networking underlying stuff, and then you got the application portion that helps actually build an application. And so over the years, we've handed off a whole bunch of primitives. We did the transit gateway like we already talked about. We've had the elastic load balancer portfolio like we haven't really talked about, but it's basically the load balancer functionality. We've got network load balancers, application load balancers, gateway load balancers, which is a whole different animal. But it's all these different bits and pieces, right? On top of that, we've got service discovery mechanisms like Cloud Map and Route 53, DNS versus API-driven stuff. A little bit of a different approach, but still service discovery. And these are all puzzle pieces. But over the last several years, we figured out like, hey, if we combine these kind of things, can we simplify this for the customer so that it is just one managed solution? And so that's the direction and kind of where this came from is can we build a product that helps solve a lot of these things without making a customer deal with onesie twosie APIs just to build this whole thing from scratch, right? If everybody's doing this and everybody needs it, can we build a solution that just does this thing out of the box? And that's kind of the place we wanted to start.
Okay. Yeah, there's a lot there.
To add a bit to that from the perspective of I think we keep having these conversations with the different personas, the network folks who are used to building or putting together those puzzles and those primitives to achieve network connectivity, as well as with the application folks who are dealing with the higher level primitives, right? The elastic load balancers and API gateway and all that stuff there. So having these conversations with these two different personas, we've noticed over time that there's maybe a perpetuation of that siloed approach from like network and applications, and like the network people do their network stuff, and we put together transit gateways and we put together VPCs and VPC peering and private link endpoints and so on, without really knowing how application folks are using those and what are the application patterns and what would be that optimized approach. Because Justin mentioned at the beginning, a step into the migration process is to actually try and see where you can optimize. So that was kind of a gray area. So I think probably this is what makes VPC Lattice one of my favorite services, is that it brings these two personas together, probably for the first time. I don't know if the first time, but for this cloud journey that means togetherness, right? Not, instead of having a siloed approach and each team building their own stuff and trying to figure out afterwards if they actually interoperate.
So I was thinking about this application networking, and I was reading about VPC Lattice and trying to understand it. I didn't want to understand it too much because I wanted to still have that perspective of I'm a networker learning what is VPC Lattice for, and I wanted to hold on to that for this podcast before I really dive deep into it so I can think of the right questions to ask. And don't let me forget, because I want to get into the hybrid networking piece of it earlier. You mentioned Justin. I definitely want to get into that. But we're all networkers here. You remember like Cisco ACI, right? Like that's like the first time I can remember application networking being a term, right? But we all know that nobody runs ACI in application networking mode, right? Everybody runs it in network mode. And, not to pull the direction in that way, but, what do you guys think about like maybe why that happened and maybe how Lattice is going to, I guess, solve that problem that kept application networking from being adopted?
I think, something like my career in traditional networking side of the house, for 20 years now, I've been hearing, we're going to build an SDN. And, the service providers a lot of the time were just like, okay, yeah, we're going to build an SDN. And all that meant was, can we do service chaining? Can we insert a firewall? Can we do this? Can we do that? And we talked about it for a long, long time. There was some marketing terms about the self-driving network, and there was other terms of just different things. And ACI falls into that category too. And they were all great advancements, but it wasn't really kind of like getting to what we all kind of thought when we were all listening, like, yes, I want to see this. But in the end, when you think about like a true SDN, think about VPC, right, in the cloud. Like that is what I would say a really good execution of an SDN, right? Software-defined network. It's true execution. And that was the first time where people did this. But why it was so successful is because we built the same primitives to help customers get there, right? Like we made the same thing that they were already used to, right? You can build a data center. It's called a VPC. You can build route tables. You can build subnets. Oh, you could have availability zones so that you can have like multiple data centers, like all those kind of things. I lost my train of thought of what the original question was.
Just how Lattice is, because ACI tried application networking and it kind of really just failed.
Right. Okay. So on that topic, like all the things we just talked about are all those kind of infrastructure components, right? It's all like the bridging the gap to help customers understand like, oh, okay, all this stuff is familiar to me. But what wasn't familiar is the things that we're actually connecting, right? 20 years ago, the concept of microservices wasn't quite there, right? And the idea of having dependencies and service dependencies wasn't quite formulated. And there were some super advanced customers talking about service-oriented architectures, like SOA type stuff. But it was kind of like nobody really kind of got it, especially the networking folks. The software folks might have understood it, but the networking folks were just like, just tell me what subnets you want to connect. Tell me what firewall ports you want to open up. Those kind of things. But over time, moving to the cloud helped customers understand like, oh, there are these things and they have dependencies of each other. How do I do this kind of stuff? And traditionally, over the last couple of years, they've been very, very disjointed. But what VPC Lattice helps with is put some definitions around what a service is in the first place. And so that when customers register this thing as a service, now I have something like that I can hold on to, be like, okay, cool. This thing needs to talk to this thing, right? And this thing is an HTTP service living on port 443, and it's hosted on a serverless platform. Like you can define these things. There's something you can grab onto. Versus it wasn't, there was never really that before, right? There was DNS where you could have like an A record pointing to something or a C name pointing to a different URL, things like that. But it wasn't quite the same as having like a definition for an actual artifact, like the thing that you want to talk to things. So that is the first kind of step. And that's one big piece of what VPC Lattice does, is it helps you define that thing.
And I think in addition to that, it's probably that's where the bringing together the application and the network folks comes in strong, in the fact that whatever network engineer you're asking about connectivity and say, okay, get me onto the network, right? The first question that they're going to ask you 99% of the times is, tell me about your traffic flows, right? What needs to access what, right? So and 99% of the answers, the times that the application folks are answering that, they're like, these services need to talk to each other, and they're like in the CKS cluster, or I have multiple clusters. I have ECS tasks, and all of a sudden the network person is like, wait, what? What is an ECS task again? Like, tell me that one more time. So there wasn't any common ground where the network person could get what they needed to actually provide network connectivity, right? Which is, tell me who needs to talk to who. And there wasn't the other common ground where the application folks could bring what they knew needed to talk to each other, right? And translate it into words that the network person could understand, which in VPC Lattice changes radically, because you have the construct of service and you have the construct of accessing a service and allowing a service to be accessed. So it's very simple. It's very straightforward. And it essentially meets both needs of the two personas in terms of starting with language, right? Like, let's try to understand what we're doing here.
It does seem like, and I think we probably all agree on this call, that there's like a gap between Justin, you called this out right when you were doing your intro. You were saying how you moved into like the higher level, kind of the higher up the stack networking. There's such a gap between traditional network engineers and then application networking. And it's like, it's almost like you guys are abstracting it so that it's so easy. Like you just have to work together because it makes it so easy to do that and to talk between the two. So I don't know. Do you guys have any thoughts about why there's a gap there? And I guess really what network engineers need to know about application networking, right? Is really the question here is why aren't they learning these things?
A couple of funny thoughts. It made me think of two different things when you were bringing this up. Is one, like walking up the stack, and I was meaning the OSI stack, right? The OSI model, walking up the stack from 1 to 7. And this has nothing to do with our conversation, but just this idea of like, when you look at that OSI model, no matter how deep you are, when you question people on like 5 and 6 layers, you're like, what the heck is going on at 5 and 6? Like, is there anything actually happening there? Like, it's just kind of like
dirtiest layers.
Yeah. The other part that I think a lot about is, I first got introduced to this idea of like a full stack developer, maybe a little bit before I came over to Amazon, where it was kind of like the hot thing, right? Like everyone's trying to hire, hey, I want a full stack developer. And at the same time, it was when everybody was not, even me, like, hey, network engineer, can you go learn Python? And I was just like, oh man, like it's one of the two. And I do know some great full stack developers. I also know some great hardcore engineering, software developing network engineers. It's just like, are you really playing to people's strengths, right? I don't think we are. And so the idea of making people learn more and be able to execute more and really trust that they're doing it right, I think that's a broken model, right? Like I'm all for people learning more, but I really think we should start abstracting things that we can so that people are freed up to do the thing that they're really good at, right? And so like a developer probably shouldn't be dealing with VPC route tables, right? They probably shouldn't even be dealing with like the compute infrastructure under there. There's probably some DevOps cloud architect that's like doing that. The developer's probably dealing with GitHub, right? And like really trying to figure out what is my product manager asking me to build, right? That's the thing I really think that they should be good at. Should they know what an IP address is? Should they know best practices from being able to implement IPv6 and things like that? Totally, like absolutely. But I don't think that they should be really focusing on making sure that their subnet mask is configured correctly. Alternatively, now if we flip the switch and go to the programming DevOpsy network engineer, do I think they should be really the script monkey or the person that's configuring the business logic and all that kind of stuff? Like, no. The thing that they're really, really good at is understanding architecture. Not just even networking, but just like scale. How do I deal with this thing?
Right.
How do I reason about my capacity projections? Things like that. Like, that's what I want my network person dealing with. And so I want to build something that gives an interface to each of these people and helps them communicate with each other, right? And I don't mean communicate like from a networking perspective, but the developer wants a super easy user experience, right? What's the thing that I need to build for that? Okay, well, I need to abstract away. I need to let them define their service, put the code, and register it. Now this thing shows up and says, okay, I'm a service. What do you want to do with it? And the developer that programmed that service probably doesn't need to do it. Like, I don't know who needs me, right? Who has a dependency on me? So now it gives the network operator, the security operator, some sort of admin, someone running the admin hat, the ability to say, cool, I want that all to go in together so that I can write common policies, configure it however I need to, and then I can share it around with whoever needs access to it. Okay? So like giving the tools and kind of controls to an admin without them having to reason about the code and having to figure out what that thing's doing, but then giving a user experience that the developer's used to, right? Like giving these things, but not making them two different layers. Traditionally, these are two different layers, right? You have the application living on one thing, you got somebody configuring load balancers, and then you got somebody configuring the network. And it's IP addresses at the network level, it's URLs and domain names at the application layer, and then it's code behind the scenes. And these are all three things that you need to look at 2 a.m. when there's an outage, and everybody's pointing it's a network problem, and you have no idea what that IP address is. Because in the container world, that IP address was like 5 different things within 4 seconds. Right? So you're like, I don't know what the heck that is. So bridging that together and making these things more unified. of course there's layers still, right? Of course there's different layers, but being able to provide a user experience that customers can actually differentiate these and everybody can talk together. I hope that kind of helps a little bit with the constructs.
And I think to the initial part of this gap and why this gap is out there, I think it is for to double down on what Justin mentioned. There's folks who are going to be good at a layer, and there's folks who are going to be good at a different layer, right? And taking my own example for when I was in college, I was like, dude, I can't see like programming. I can't see the beauty of it. I'm not going to be a brilliant programmer because I don't have that spark, right? So what else can I do? It was like, networking. And then I took my first Cisco class, actually, and I did a ping between two virtual routers in Packet Tracer. I remember it today. And I was like, my God, this is working. And that was my spark, right? And I truly feel that there's a lot of folks out there who are like, I don't want to deal with the network because I don't like it, and I'm very good at what I'm doing, which is this software development piece, and the same in the other boat. And I think that at the end of the day, talking or having the possibility of talking that same language has been a big gap so far because of the lack of probably words and primitives to get there. I remember that probably 99% of my 2 a.m. Calls and tickets that got escalated were my application is not working, and my question was, okay, can you show me what's not working? And I saw like a curl that was timed out, and I'm like, okay, can you tell me more? Like, I don't get what's like. Tell me your path. Tell me your VPCs and NACLs and security groups, and are you connected to Transecure or are you peered? Which transformed essentially into a session of 2 hours of them describing to me their architecture. So I think that's where the probably the biggest friction point is, because network folks ask for something, application folks deliver something else, and the other way around. Tell me your flows. Let me think about that.
Yeah, that's a great call out, because I think just going based on that, the VPC Lattice, from what I know at least, is going to change that conversation, right? You're not going to say, hey, my curl isn't working. You say, hey, this service that I'm subscribing to isn't working, or something like that, right? So I guess based on that, maybe we should kind of circle back and go through what the basic constructs are of VPC Lattice, because I know we've talked about, registering a service and a service directory, things like that. So maybe let's go over the basic components. We don't need to spend, hours on it or anything, but I know there's a lot to it. But can we cover like maybe what the basic constructs are for Lattice?
Sure. Yeah, so these are all new features and constructs built into VPC. So if you're familiar with VPC, that's a good starting point. You're already most of the way there. We introduced kind of 4 new things. Okay. The first one is this concept of defining a service. Okay. And this is behind the scenes, just a DNS URL. Okay. It's just a DNS URL. Behind it is something that's configurable, which is listeners, rules, and target groups. Okay. And if you're familiar with kind of the Elastic load balancing portfolio or products, it'll be very similar, where this is where you can actually define what this service is. This is maybe an HTTP service, maybe it's HTTPS, and you got TLS on it and stuff like that. And I'm listening on port 443. Maybe I put some rules in there to say, if you get a GET request, send it to this target group. Your target group is basically like the back-end compute that's actually running the software. You might have a default, maybe you don't have any rules. Maybe the rule is just like, if you come in on port 443, send it all to this Lambda function, or send it all to this EC2 instance. So it's basically, a service is just kind of a definition that you are basically saying, I'm going to register this thing as a unique entity that somebody might have a dependency on. Okay, so that's first and foremost a very important primitive.
Are there, real quick, what can be a service?
Yep. Perfect. So today we support HTTP and all the different variants right now. So that is things like gRPC services, an HTTP endpoint, an HTTPS service. Think like APIs for the most part. There's much more than APIs. Right. We've got some customers that are doing database connections over HTTP and things like that as well. But right now, it's really HTTP endpoints, which is kind of those API transactions in a microservices type world. It doesn't have to be microservices, but does that kind of make sense?
Yeah, it does. Yep.
Okay.
So when we register the service, then the service is just a logical stand-in for the actual, like it's a logical created rule set, if you will, for the thing, is what you're saying?
Yep. It's a like completely made up place marker that says, hey, I'm gonna give this thing a name, payments, right? This is my payments app. I'm gonna give it a name. And then behind it, payments might be a bunch of different things, right? Payments might be payments / user one, right? Or header equals user agent equals Justin, or all these different things. Those would be microservices within the service, right? So you can do all kinds of things. But what the VPC Lattice service is just this logical kind of front end, saying, hey, here's a DNS address. What do you want to do behind it?
And I think you, Justin, mentioned the pieces related to application that are part of the service. But another super important piece of it is that a service can span across multiple compute types, which I think is great from the perspective of, I do have a service that's running on EC2, let's say, right? And I'm actually wondering, how will my service perform if I would put it on a Lambda function, or I would put it in EKS and containerize it? So what you can do is abstract behind that service payments, right? Target group one, that is your EC2 auto-scaling group, for example. Target group two, which is your Lambda function, or your EKS service, right? And you can say, well, I want to actually see how it works, right? So you reroute part of the traffic using weighted target groups within Lattice, within the Lattice service VPC service definition. And you can say, I want to send 10% of my traffic to my Lambda function and see how it works. And if it works fine, you can continue with your deployment. So it is. It also gives you the ability to span services across multiple compute options, which goes a bit into the network aspect of things, because usually to get services to sort of get that type of connectivity or front end between multiple compute options, it requires a lot of networking under the hood, right? It requires that connectivity setting across VPCs, accounts, and so on.
It makes me think of like if you're refactoring an application, right? And it's like a more monolithic style, right? It's running on some EC2 instance, and you're trying to refactor it into a microservices architecture. That's amazing, because you can break off pieces of it and just route to like a chunk, one of the microservices.
Yeah,
and
as you
peel
start
it off,
migrating.
right? Yeah.
And one thing that we've actually discovered last week was that it is actually the answer to migrating to IPv6. I love this. So it's been the crux of all network engineering folks' existence of saying, application folks, you got to get to IPv6. And application folks would say, oh, but we don't know how our application is going to break if we put it on IPv6. Well, with VPC Lattice, you can have a service with two target groups, one on IPv4, one on IPv6, and you can slowly migrate traffic to the IPv6 target group, and you can see if it breaks, irrespective of whatever your client is doing. It's a complete separation and abstraction of IP addresses.
Oh, lots of people are going to love that. Yeah.
Yeah, to double click on that one, because I think from networking folks, I think a lot of your audience, probably hardcore engineers, would probably like this. I'll go a little bit deep, but not too deep, and then we can always come back. But essentially, we're abstracting away the underlying IP type stuff for customers. Again, like we touched on before, like I think until we die, all that stuff's still going to be there, like under the hood. It's just layers of abstraction on top of that, right? That's all. Like if you came in one of our data centers, you're going to see routers, you're going to see switches, you're going to see lots of IP address communications. But we're abstracting this stuff away, right? And so with Lattice, it's the same kind of idea. And what Alex was touching on with the V6 stuff is when you register a service and when customers connect to that service, we want it to be kind of invisible from an IP perspective. Okay, so when I register my service, it could be on IPv4, it can be on IPv6. It doesn't matter. It's in some VPC and it's something. Once I register it, I give you a DNS address. And by default, when I give you that DNS address, I configure it with V4 and V6. Okay, it's dual stack to begin with. You might not even be on v6. You're going to get a v6 address anyway. Okay, and so I don't care what your app's doing. You don't need to refactor anything. It can do whatever it's doing. Now, when the client goes to do a connection and say, hey, I want to talk to you. If that client is on v6, well, it'll just connect via v6. If it's on v4, it will connect v4, right? It gets that DNS response that, hey, this is dual stack. Which one do you want to use? And you can connect to whatever you want. Lattice will then get that request and figure out what to actually do with it. Send it to that service. It does the network address translation for you. You don't even need to think about that, but behind the scenes, it's all doing that stuff for you. Okay? So this idea is that even though those IP addresses are there, we don't necessarily want the developers and the people that are managing these things to have to think about them. Right? We want to abstract that as much as possible to give it a much more user-friendly experience. The admin, of course, has knobs that they can dial into and go and look at things and all that kind of stuff. But it's not on by default. So it's very, very simple by default.
And I think I already know the answer to this, but so does that change whenever the product is expanded to support more than just HTTP, gRPC type payloads? Like if we move further down the stack with regard to IPv6, do you see that changing, or is there going to still be that level of transparency where the user just has no idea?
With HTTP, we can do a lot of cool things. Especially if we participate in the TLS handshake. If it stays encrypted, there's not much we can do, right? It's just like, okay, what is it? But if you participate in TLS, right, and you have that handshake where VPC Lattice is the gating process, we can look at HTTP headers. And that is super powerful, right? Because then you can figure out what does this thing actually want to go to? And that's a much more rich set of things I can look at to do different instructions. Like, oh, cool, the user agent says blah, send it here. Oh, the host name says foo, send it to there. Right? So I can do a lot of manipulations based on that information. As we go down the stack, right, to other protocols, which we're looking at right now, but we don't support yet, that some of that stuff will need to go away, and it'll be less abstractions. But we'll do as many abstractions as we can. Right? So if you think about something like layer 4 or TCP, what is a TCP connection? Well, it's an IP and it's a port. And so you can abstract that by making it very, very simple and not making the customer define what IP address it is and what port it is and stuff like that. But still an IP and a port. And so the real benefit is when you do start to walk up that stack, it's again, more and more abstractions that you can create without having to be, just very easily.
Right. So basically, you want everyone to just build HTTP apps, and then all the problems will be solved, right? No,
I think most customers that are more on that kind of microservices journey, or just have kind of service dependencies, and I don't like the word microservices, to be honest, because I think when I talk to some banks and things like that, these are very, very technically savvy organizations a lot of the time, but they, on purpose, don't move super fast, right? Because they have compliance and different things that they want to look out for. And the term microservices to a lot of these type of banks and things like that is terrifying to them. So they're like, hey, I've got this app. It's never going to change. It's 40 years old, so on and so forth. It's a big monolith. And it works great. And it's secure and all this kind of stuff. That's what I understand. And that's totally fine. That, to me, is a big service. And that thing might have multiple services in it, right? And it might have a dependency on something different. It's an API or something like that. What I find when I talk to most customers is that most of the service-to-service type transactions are HTTP. And then you got about 5%, 10% of it that's something different, right? Your database connections and things like that. So that's kind of where we started with HTTP. And I think it covers most use cases. But for those other ones, VPC Lattice isn't changing VPC as you know it today. It adds a whole bunch of new features and functionality to it automatically when you turn it on. But the VPC is still the VPC. If you do a DNS request and you're looking up some service that's behind a private link or behind a load balancer and transit gateway and all these other primitives, it's still going to get there, right? It's just going to take the other path. If it sees and knows about it in Lattice, it'll go take Lattice. If it finds it and it's something else, it'll go take the other path. So I want to be conscious. We've only talked about service right now.
Yeah, I was say, I know we've taken some time there. Sorry.
No worries. I think it's a very important thing. And it's new to a lot of people that are in the networking realm, right? And so it's really important. I say, take time to understand that primitive because it is a very important one, right? Everything is built off of that. right? If we didn't have services, what are we doing? There's
Right.
nothing, like if I go, if I'm trying to think of if I go to Instagram or something like that, like, what is it? Okay. So now that that's there, we need a place to actually see all the services I create and all the services that were shared with me. So we created a service directory. This lives in the VPC console, and it's nothing more than just a visual representation of all the services that I created or that were shared with me. We can get into that in more detail in a minute here, but it's just a service directory, okay? The developer likes it because it's one place that they go to. They copy the URL of the service they want. They put that in their code. They connect to it, okay? That's why the developer likes it. Good user experience. The admin likes it because it's one place to say, what the heck does that account have access to? What are all the services it created, and what are all the services that were shared with it, right? So it's, again, you'll see this as a theme of like the personas, right? What's the tool for the admin? What is the user experience for the developer? Of course, we care about the user experience for admins too, but that's all of us, so we're fine. So, okay. Any questions on the service directory?
Yeah. Can you see, like, how do you see it? How do you consume it?
Well, there's an API call. You can do the CLI, or you just go to the VPC console. Just log into AWS, go to the VPC console, and you click on your services, and you will see the whole service directory there, all the services that were shared. It's an account level view. If you're super savvy with AWS, this is also an important reference. So it's all the things that are within your account. And so if a different account shared something with you, you can share a service. You'll see that as well. Now, all these things were created. They live in the service directory. They're just sitting there. What the heck can we do? We want to do something with them, okay? So we created something called a service network, okay? You can think of this as a grouping mechanism for these services, okay? So everyone on here has probably been around the days when you were going through basic networking classes where you learn things about like non-networking type stuff, like Active Directory, or this concept of users and groups. You can configure a bunch of users, and you can put a bunch of permissions on them, right? But if you got thousands of users and you want something applied to all of them, it's kind of tedious to do it to 1,000 users. So you create a group. You put all the common stuff on the group, and then you put the most specific stuff on the user, right? Same concept here. We created a grouping mechanism called a service network that allows you to put services in there. And this helps you do 2 or 3 things, okay? The first thing is you can apply common permissions. We can go into what that actually means, auth policies, as to who has access to talk to what, okay? At the service network level. You can also do it at the service level, same way you would with users and groups, okay? So it's just a collection. I want to point out that this is different than a service mesh. Some customers like to think of, hey, is this a service mesh? Is this not a service mesh? Totally different. Okay, so don't go down the path of thinking this is a service mesh. It'll break your mental model, and just don't go down it, okay? We very purposely said we didn't want to build a service mesh. So this is a service network. It's a grouping mechanism. Just because you put your services in it doesn't mean they can all talk to each other. It's just the grouping mechanism at this point, okay? To get connectivity to the things in this service network, you associate it with a VPC. And that is the network connectivity piece. Once that is enabled, once you take that service network with all the services in it and you associate it to a VPC, now everything in this VPC can discover it and connect to it. A grouping mechanism for policy, it's also the thing that's used to implement the connectivity. The admin in an organization typically owns this thing, runs this thing, okay? The developer or some sort of DevOps person typically owns the service. You can also turn on centralized observability on this thing. So it's like those are the 3 things you can do with it. You can put policy, you can enable connectivity, and you can enable observability, like logs and metrics, to a centralized place.
In my head, I just like, and again, I purposefully did not read too deep on this so that I would have, so that I could be, you could explain it and I could have the right questions. It sounds like what we're talking about is like almost like an orchestrated set of private links to a grouping, a logical grouping of these services. Is that fairly accurate?
I love it. Yeah. No, so it depends who I'm talking to. we always end up like, I love listening to Alex actually describe this stuff when she's talking to customers, because she does it a different way than I do. I do a different way than her. And it all depends on who the audience is. Because if it's like a service mesh type customer, I start out and I say, hey, so it's kind of like a service mesh, right? Where it's doing connectivity. It has a lot of the same features and functionality. It's just implemented a little bit different. To a more network savvy audience, I typically go down the route of saying, like, what if you combined an application load balancer and a transit gateway, right? What if you combine those two things? But to some customers, they're like, oh, but it's kind of like private link too. It's like handling that and all that kind of stuff. Absolutely, right? Like, these are all things, it's higher level than private link. It's L7 versus L4. But this is exactly the same kind of construct. But instead of having to deal with ENIs and kind of all that kind of stuff, subnets and all that, it's a much more abstracted version of it. Over the last 7 years, we've seen customers using things like API Gateway, things like Transit Gateway, things like App Mesh, things like Private Link, things like blah, 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 blah. This is taking that fresh look and saying, okay, now we understand how customers are using these things. What if we built a more simple version that bundled these things together? Okay. Behind the scenes, it's not really these things bundled together. It's a new platform, but that's the kind of mental model. We understand how modern applications talk to each other now. Let's build a system for that.
Yeah. If you saw me laughing a lot while you kept saying the service mesh portion, it's because even though I'm very much traditional network engineer, I have always been, as soon as I saw this, I was like, this is like a service mesh immediately. Yeah. And it's interesting because I had originally thought that it kind of came from that model, but the more you talk about it, it just seems like it is so different in so many ways that I wouldn't have got the nuance unless you started explaining some of this stuff.
And I mean, you'll even see in a lot of our marketing material and different things that we talk about, we do frame it as in that same kind of category as a service mesh. The thing I like to tell people, though, is just don't think of it like that, because a service mesh is very specific to a containerized platform, right? And I think that's
architecture.
Great. Yeah, container architecture, mostly Kubernetes, right, specifically. And I love that. And we wanted to make sure that we built a very native experience for that, but we didn't want to limit ourselves for that, because there's a lot of customers that just aren't just Kubernetes. Like, there are a wide range of things, and they still need those features and functionality. And so if you look at the traditional service meshes that are out there, some of them have actually started to say, okay, you can do it on EC2, you can do it on this, you can do it on that, and mixed platform. But it's like really painful to get there, right? Because it wasn't built for that. And when we looked at this, we said, okay, what would it look like if we built a platform that was universal to the underlying compute? And that's where we started, right? And saying, okay, these are the features and functionality that our customers are asking for. Let's build it in a way for all of these so that the admin doesn't have to qualify saying, hey, you know what, developer, you're only allowed to configure on EC2 because I haven't quite qualified ECS or EKS or Lambda, right? Because I need to figure out how I'm going to handle authentication, authorization, all these things. By abstracting that, now customers can say, okay, I'm standardizing on Lattice. And then if you want to use Lambda or EC2 or EKS, do whatever you want, because I have a common set of tools here and I've abstracted away whatever you're doing behind the scenes. And I know that I can still meet my compliance.
You know, again, coming from expanding out the service mesh concept, like you said, people are expanding it out to more than just microservices slowly, but it's always like a sidecar proxy model, right? And it's like you guys have already skipped that step and expanded it out, and that's where it's like it's so different than how the sidecar, how that industry is approaching it, how the service mesh companies are trying to approach it.
Yeah, I think I'll point out we kind of cheated, right? Like, we have this magical thing called the VPC. And we have things like Nitro, and we have these very powerful constructs under the hood that we could build something like this, right? Like, if you tried to build it on top, you can't, right? Because it's like we're using a lot of this underlying connectivity to do this. With that being said, I will say that there's a ton of cool things that you can do with a sidecar. The problem with the sidecar model and the traditional service mesh is that we've looked at this cool little shiny thing that you can put next to every workload, and we said, awesome, let's just do everything in it. And it's like, when is that ever a good idea? It's never an all or nothing, right? It's that whole centralize, distribute, centralize, distribute. There's certain things, certain features that you make a lot of sense to put next to the workload. Keep doing it. If you want to do a sidecar for just those, cool. Don't put your kitchen sink there, right? There's no reason that a full-blown proxy and all of your service discovery needs to happen at every single node. As you scale up, like disaster mode, right? So pick and choose what you want. What VPC Lattice does, it says, we're going to put it all in the VPC, natively, outside of user space. And then if you want to put things inside, cool, go for it, but you don't have to. All right, so we talked about service network, we talked about service directory. The last one I just want to point out is auth policy. And that is just basically an IAM resource policy. And that might be unfamiliar to a lot of folks that are not necessarily dealing with AWS all the time. But this is basically the thing that powers any of your authorization, billion requests per second type thing, billion authorizations per second kind of thing. Instead of it just being for AWS APIs, which was what it was before, now you can do this for your own service-to-service communication. So hands-free, hands-off, secrets management, authentication authorization. So this is what VPC Lattice uses. It's IAM. And you can apply these auth policies to define who can talk to what at the service network level or at a service level. And this gives you control for treating it like users and groups, right? Put some coarse-grained stuff at the service network. These are your guardrails that the admin's just like, as long as this comes from my organization, I probably won't show up on Hacker News, right? And then the service side, be more specific, like only principles that are PCI compliant and blah, 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 things like that.
Yeah. So, I mean, thinking in terms of the networkers out there, the admins out there that are currently building, they're using Transit Gateway, they're using VPC peering, they're using everything, Direct Connect, everything under the hood to build the communication highway for these services as they are now. Let's say without Lattice. How do these things kind of commingle with the other network offerings that they're using day to day? Because I think people have seen this and be like, oh, they're taking things away from me. Like, I'm going to lose admin control and things like that. So, how do these things kind of play together?
I'll take that. The reason for it is because that was my first question as well. Hence, we've created a reinforced session, which was just last week, about AWS Cloud WAN plus VPC Lattice plus verified access working all together. And I'll share the link with you.
Yeah, when you get that.
Absolutely.
Nice. Yeah. And I think that's probably the first question that comes up whenever I talk to the network persona is, okay, cool. So how do I integrate this with my environment? That's one. How do I continue to manage? How do I continue to have that overarching control over the things that I need to have control over, so that I don't have my developers doing all kinds of crazy things. But at the same time, how do I enable my developers, right? And probably some of the most common questions is, how do I connect multiple EKS clusters across multiple accounts, across multiple VPCs? How do I overcome the overlapping IP space problem? How do I get to IPv6 and so on? So the fact that, as Justin was mentioning at the beginning, service discovery is DNS based helps admins control what gets solved for by VPC Lattice. And actually, one of the use cases that we presented in the reinforced session was access to shared services from VPCs with overlapping IP space. That's probably 99% of use cases that everyone wants to get to. Also from multiple routing domains or environments, right? So let's say you have one instance of your artifact repository, for example, and you want that to be accessed from both prod and dev and stage and whatever. So you can choose as an admin which use cases you address using VPC Lattice. You can choose, or you can continue using your transit gateway network or your cloud WAN network, your direct connect, your internet connectivity, your inspection architectures for internet ingress egress, or for VPC to VPC communication, based on your needs, and you have full control of that. So I think that's the added, very powerful feature of VPC Lattice, the fact that because it operates at under the hood in the VPC, right? It's able to attract that traffic that needs to go to it without impacting your normal routing, BGP policies, everything you're doing nicely in your global network.
Yeah, we wanted to build something that was completely non-intrusive, because I think we did a lot of kind of soul searching with customers on, what do they want to do? What does next generation look like? Some of the customers had already adopted service mesh, things like Istio. Most of the other customers were like things like application load balancers. And the thing that was very clear is like, it's very tough to go all in on something like service mesh. And it really is that, right? Like I need to go all in. How do I do that overnight? When we were drawing up the board, we're saying this is just impossible. We need to make it so that it just works. If I want to put one service in and that's all I want to do, how do I do that, right? I don't want to put all my things in. And so the way to do that is to use normal constructs that we all are familiar with. DNS, right? We don't need to get super crazy with service discovery. DNS is great, and it's been working for years and years. There's some tricks we've done to make it more optimized, right? So that you're not constantly worrying about having to get your TTLs issues figured out and all that kind of stuff. But like those kind of things, you put services in as you want to enable them. If the customer looks up that DNS and it happens to be behind Lattice, it just goes there. If you're looking at anything else, it just goes there the other way, right? So it's just normal protocols. I think the network engineers will really like that because it's not anything weird. It's just the normal stuff.
It's nice to know that no matter what, the problem will always be DNS.
Always be DNS.
That's what I'm hearing.
As long as they're not pointing at the network person, let's go point at the systems engineer, the DNS person.
So this actually is a good segue, because I was going to ask, and I know we're running out of time here, but I think this is really important, especially to the networkers that are going to be watching or listening to the episode and thinking about Lattice. A lot of them, their first questions are going to be like, all right, well, how do I monitor and troubleshoot it? Like, how do I know when Lattice is having a problem? Because it's the more we sweep under the rug, you lift up that rug and it could get pretty ugly under there. So what's your feeling there?
When we talk about more we sweep under the rug, I actually have a different kind of feeling about it, because while that is the case when you think about managed services, when you have a lot of them teamed up together, it can be really challenging, right? Because you're like, not only do I not have visibility, but I have a lot of different places I need to look. But VPC Lattice is actually taking kind of a different approach, right? It's saying, I'm going to make you deal with less, right? You're dealing with a lot less. And so as long as I provide you the observability so that you can see when things are coming in, you're not looking at a whole bunch of different hops. There's one. You log into one thing and you look at that, right? And it gives you a very, very simple way of kind of seeing, is my service broken? Is my service not broken? I'm not needing to look at all the underlying bits and pieces to figure that part out, right? And I think that's actually very appealing to a lot of customers. Again, it's like the cloud journey, where some customers are like, I'm terrified of the cloud. Then they get in there and they're like, okay, this is actually really helpful. Same kind of thing here. The other part I would put it on the observability front is that another theme that we saw was that the developers had some sort of tool that they were using. Prometheus, Grafana, whatever it is, right? The admins are like, no way, man. I'm using like Nagios or Nagios, however you pronounce that. And I'm using SolarWinds and Splunk and all these kind of things, right? It's like very different platforms that they want to use. On top of that, the admin's like, developer, 2 a.m., why didn't you turn on your logs and metrics? Like, we can't even figure this out, right? And it was very, very hard. So what we wanted to build was a place that the admin and the developer had the same logs and metrics, but could use it however they wanted to. And so at the service level, you can enable logs and metrics and send it to wherever you want to send it to. You can send it to S3, CloudWatch. We integrate with Kinesis Data Firehose. You can send it to whatever platform you like. The admin, though, this is the power, at the service network level, can turn it on for all services in the network, regardless if the service owner turned it on or not. And they can send it to their platform of choice. And so now you have this kind of very, very auditable kind of situation that gives you those rich metrics and logs. Now, here's the big part. Again, we talked about like IP addresses not making sense in container world. I'm not dealing with IPs anymore. Of course, you'll have them in your logs and metrics, but you're going to see service A was authenticated with and allowed access to talk to blah, and they did a GET request at blah, blah, blah timestamp, so on and so forth. Right? You get those rich metrics and logs to understand what's going on.
That's interesting. That's cool.
Yeah, thanks.
And the added piece to that is that, again, those access logs show the totality of information that's meaningful for the service owner and for the service network owner, for the admin, right? And you stop looking at two different things from two different perspectives. You stop looking at a curl that timed out versus at a ping that doesn't work, right? So that's kind of the again, a place where these two personas come together and look at the same thing at the end of the day, and troubleshooting is much easier.
Yeah, bridge that gap, right? Like, it needs to be one thing because it is one thing. Right now, we're developing things on different layers, and we're saying no. The only reason why we're doing that is because we don't want to have to build and hire really good full stack engineers. They're hard to find if they even exist. And we don't want the super Debbie network engineer. Bring it down, provide the right user experience to both, and make it the same thing instead of having two different things.
I think you guys need to, VPC Lattice, you need to work your way down the stack to where I can do ICMP. So if I can't ping the service, it doesn't work.
I don't know what it is if I can't ping it.
Yeah. Well, I'm just going to sure there's a GitHub for ICMP wrapped in HTTP somewhere.
We should add that to the roadmap, Justin, please.
There it is.
I need to send gets as ICMP. Yeah.
All right, I got a super quick one. So, and this might have been covered, and this is weird to even say because I'm going to call an overlay an underlay. But is there a way to have, like, do you have to have a network already established in AWS to have the overlay of VPC Lattice service network running over it? Does that make sense?
Just a VPC or?
Yeah, like does the VPCs already have to be peered? Like, is there any kind of requirement underneath, or does Lattice just come up?
This does all this for you. So most of the time, customers think of Lattice as like the network and load balancer thing put together. They handle all the cross VPC stuff. Behind the scenes, we're not actually doing VPC peering and all that kind of stuff. You don't need to do that. You can completely isolate your VPCs, not have a network at all. The major magic is that once these services are all registered, now VPC Lattice has this thing. It's like, oh, cool, I know about all these services. And so now all you need to do is just share them like you would a private link. And that is that setup. But I do want to point out that it doesn't have to just be for network connectivity. VPC Lattice is a full-blown proxy. Instead of having to configure a subnet and put an application load balancer in there in one VPC, Lattice does that too, right? It is a proxy. And so I don't care if you are in a different VPC or you're in the same VPC. None of that stuff matters to me. All I care about is that you registered your service and you're a part of that service network. If that's checkmark, I can connect to you as long as the auth policies allow, obviously. So
okay. Well, then, so that's perfect. So this goes into the last question.
Yep.
The last question is what's the most interesting deployments that you guys have seen with this product?
Interesting. I mean, I would recommend reading Alex's blog that covers probably my favorite of the architectures. But I'd say that we originally were focusing on the developer user experience, right? We were really kind of focused on how do we make this just super simple? And so this idea that I didn't even need a network admin. My developer could have its own service network. I could be running in Kubernetes, configure all my services, and then just have everything talk to each other. That was kind of the angle we were going. How do we make it so simple? But when we started shopping this around and kind of talking to different customers, it was very evident that it made a full-on switch where the admins were like, oh no, this is the way that I can still give the developer that experience, but now I've got that centralized place to control it. And so I think kind of the most popular architecture pattern that we've seen is really along this lines of an admin of some sort creating a couple of different service networks, one for maybe PCI compliance, another one for shared services, right? Them being the gatekeeper of what goes into this. Only PCI compliance. I did my due diligence and I verified that these are all compliant type workloads. And then sharing that service network out. You can share service networks or services. I don't think we covered that. But being able to do that, own that network and share this thing around is the really, really kind of powerful one that I think most the bigger customers are interested in.
Justin mentioned the shared services access, but I think the access to that central artifact repository, central code repository, everyone in prod and dev needs access to this service. How do I do it? Well, so far you either had to do east-west inspection on transit gateway, you had to do private link in every single VPC, you had to do something, right? Well, with VPC Lattice becomes much, much more simple. And it also enables that zero downtime type of migration. So essentially, it's just a DNS change. It's not interrupting your production workloads or that flow. So yeah, I think that shared services piece is super important, especially when so many large scale environments that come from acquisitions and all of that have overlapping IP space.
I want to say one more architecture, just because you just made me think of one. The other one is really just this idea of isolation. Just the same way that when we first launched VPC, we never thought the customers would have more than one. Right? Like most customers don't even have a data center; they rent space in a data center. That quickly changed. We've got customers with hundreds of thousands of VPCs. Same with accounts, and customers really like this idea because it's two boundaries that they can wrap their head around. Right? Network boundary, VPC. Account permissions. Those are two boundaries. But in this model, it allows you to kind of really isolate and say, okay, I'm going to put an application in this VPC. All the major dependencies might live in it. It's got its database there and all that kind of stuff. But when I have like that front end that I share with everybody else, that all my dependencies need to call, today we open this VPC up. Whether it's the internet gateway, VPC peers, transit gateways, we open it up. And it, like in all reality, do I want to open it up at the network level or do I want to open it up at the service level? And that's what VPC Lattice is really, really kind of good at handling, right? It's allowing these customers to get that kind of really isolated reduction of blast radius kind of situation where I cut off all connectivity from my VPCs. I give all my application owners their own VPC to do whatever the heck they want. They don't get internet gateways. They don't get transit gateways. They don't get anything. Pick and choose what they want to share. And then that's it. And so now it's completely centralized control of all of that kind of stuff. So that is kind of the big, big magic bullet there.
Yeah. What you just mentioned, Justin, reminded me of a customer who, not actually just one customer, multiple customers who've created VPCs purposefully with overlapping IP space so that they would never peer with each other and they would always have control over what connects to what.
That's
VPC
heavy-handed.
Is the thing that enables you to do that, maintain that control, not care about the overlapping IP space.
Okay. Well, this was amazing. We got to cut it at some point. I was going to ask, we'll have to get some links. We didn't talk about security. So maybe it'd be good to get some links that talk about some of that stuff. But I'm going to just go around the table real quick. Chris or Tim, anything you want to chime in? Any last words?
Yeah, I will say this was super helpful. Thanks, Alex and Justin for coming on. This was, I actually did opposite Tim. I did quite a bit of reading before coming on this call, and I will say I walked away with quite a bit. So this has been very well. Thank you.
Yeah, it's really good. I'm glad to hear about it. Again, I did the opposite of Chris, which is what we normally do, but mostly because I wanted to have that perspective to ask those questions, right? And having heard all of it, I'm really excited to actually go now do the really deep in research and start playing with it myself. So thanks for making the time. It's been excellent.
Thank you.
Happy to do this. I think it's a new primitive for a lot of folks. And I think even though we built the user experience for developers, people that built it were all admins, right? So, Alex, myself, we've got that kind of same background. So there's a little bit of something for all of your audience there.
And I think based on everyone's reaction, and if folks are going to get questions or feedback, we'd love to come back, talk some more, go more in depth. So
sounds great.
Absolutely, yeah. I'm sure there's going to be a lot of questions. So, okay. Anything you guys want to plug? Where do we find you guys online?
Oh, for me, it's LinkedIn. Just search Alexandra Huides and you'll find me there.
I think LinkedIn's probably best for me. I think I'm Mr. Justin D. I think every time I'm on Twitter, I just paste my LinkedIn posts. So I haven't quite figured out that platform yet. But yeah. It's probably the best place.
All right. Awesome. All right. Well, thank you all very much for tuning into the Cables to Clouds podcast. If you like this episode, please share it around to anyone you think might be interested. Give us a 5-star rating on your favorite podcatcher and hit those like and subscribe buttons on our YouTube channel. Until next time. Hi, everyone. It's Alex. And this has been the Cables to Clouds podcast. Thanks for tuning in today. If you enjoyed our show, please subscribe to us in your favorite podcatcher, as well as subscribe and turn on notifications for our YouTube channel to be notified of all of our new episodes. Follow us on socials at Cables2Clouds. You could also visit our website for all of the show notes at cables2clouds.com. Thanks again for listening, and see you next time.